Hey guys, it is May the 4th when I'm recording this, so happy May the 4th. I wish I could be there with you and do all the fun stuff that I had planned, but anyways, we'll just move forward with that, we'll try to make the best of it. And yeah, okay, so I'm gonna go over the homework from, well, I posted it today, but you're seeing this tomorrow, so I'm gonna say yesterday, homework from yesterday, 11.3, page 808, numbers 1 through 17, odd. So I know that once we get here, it was kind of hard to see 15 and 17, which is why I posted a picture of my little Post-it note and me writing out those things so that you can see them better. So hopefully you guys caught that. These were pictures that Mrs. Ardito gave me of the book because I don't have the book that goes with these. So I'm kind of stuck here. So I'll do the best that I can giving you guys those problems. I would never assign it to you if you couldn't see it. So if you ever have trouble seeing it, just email me, let me know, and I will tell you what it is. But the ones that I know for sure, because I can't see them, I will make sure that you have them, okay? So I'll write them in for you or attach it, okay? All right, so anyways, number 1, it says, use the figure to approximate the slope of the curve at the point x, y. So I'm using the graph, and I'm going to go ahead and get my paper ready here. This is 11.3, page 808, numbers 1 through 17. We're doing the odds. Okay. I like to get that ready. Okay. So you don't have to copy down the graph for these, so don't worry about doing that. These are actually really easy. Let me switch to a lighter color that we can see though. Okay, so we're finding basically the slope at this point right here. Okay, and so that's where we have to come up with a tangent line to it. And we have this line right there, and it's a horizontal line going through y equals 2. And when it's a horizontal line, the slope is always 0. So this one's super easy. The slope is 0. So you could put slope equals 0. You could put m equals 0. It's up to you, okay? So that one was pretty simple. Number 3, because we're doing the odds, is the same thing, but I'm going to go ahead and zoom in on this graph. Okay. And someone obviously had written in pencil on this book that Mrs. Ardito took a picture of, so I'm going to ignore that for right now. But I need to find the slope of this tangent line to this curve. And I have this exact point right here, 1, 0. And I kind of will use a little bit of this person's writing. Remember that, or if you look at this page, obviously it was turned kind of like this when it was taken, when someone took a picture of it. So it wasn't flat. So whoever wrote this in, it's not that they didn't write it straight. It was just the page was turned so it looks like it wasn't. So, okay. So I'm looking at where this person drew this point, because that is an exact point on that line, up 1 over 3. Okay, and that is, and I didn't really need to say that, but this point is the point 3, 1. Okay. All right, so what we can do is we can find the slope between those 2 points. Remember the formula for that? So I'm going to write that on my paper. M equals y2 minus y1 over x2 minus x1. You're ride or die. You got to know the slope formula type thing. And the 2 points that we have on that graph were the point 1, 0 and the point 3, 1. Okay. It doesn't matter which one you label your x1, y1 and x2, y2, but be consistent. I always go in order just because you don't have to think about it. You just do it. All right, and let's go ahead and plug it in. So m equals, let me zoom out just a tad. All right, so y2 minus y1, that would be 1 minus 0. Over x2 minus x1, that would be 3 minus 1. So I would get 1 over 2. So the slope of that tangent line is 1/2. Easy peasy lemon squeezy. All right, now we're on to number 5. So we're out of the graphing part of it. And it says use the limit process to find the slope of the graph of the function at the specified point. Use a graphing utility to confirm your result. So what you can do is you can graph this like on Desmos and plot that point and then see for yourselves what the slope of that tangent line would be. Or we could just do what Mrs. Ardito showed us in the video, which is what I'm going to do. So they gave us the function. I'm just going to copy it down. G of x equals x squared minus 4x. And it is at this specified point 3, -3. Okay, so we have to remember that we're using that the limit process formula. So it was the limit as h approaches 0 of, in this case, it's g of x. So g of x plus h minus g of x all over h. Okay? So now we just have to substitute in x plus h into the x's up here. Okay? And then simplify this out. So I'm going to use different colors each time because I like to do that. So I'm going to have the limit as h approaches 0 of, now I'm going to plug in x plus h for the x there, so I'm going to have x plus h quantity squared minus 4 times the quantity x plus h, then minus g of x. Well, g of x was this x squared minus 4x, so because it's two terms, I need to put in parentheses because we're going to have to distribute that minus sign, and if we don't put parentheses, we will forget. So we got to be proper mathematicians, especially at the calculus level. Okay? All right. Next, the x plus h quantity squared. Remember, that's the same as x plus h times x plus h. Okay? And we would FOIL that out. So hopefully, since you should have done this enough by now, especially if you've already done this homework, you'll have it memorized. You'll know what it is because you're going to get this a lot. So you should get x squared plus 2xh plus h squared. I'm not going to go through foiling that out. You can do that, okay? But this is the answer. So if you didn't do that and you want to check yourself, then press pause, FOIL it out, and see that you get this, okay? I'm going to distribute that -4. So we'll get -4x minus 4h. And then I'm going to distribute this negative. So I will get -x squared plus 4x. And this bad boy is all over h. Okay? So next, let's see, does anything cancel? I have a positive x squared and a negative x squared, so those will cancel. I have a -4x and a positive 4x, so those will cancel. And that's it. So now I see that I have 2xh, h squared, -4h, all over h. The idea is to get that h out of the denominator, we need it to cancel because when we plug in a 0, it makes it undefined. So since all three of these terms have an h in common, we can factor out an h. So we're going to have the limit as h approaches 0 because we have to keep writing the limit until we plug in numbers. All right, and we have, let's factor out an h. If I divide out an h, I will have a 2x left in this term, an h left in that term, and a -4 left in that third term. All over h. H's cancel. Now we can plug in stuff. What do we plug in? Well, first of all, we're going to plug in a 0 for the h. Second of all, remember, we only worry about the x value. Remember Mrs. Ardito would cross out the y value? We don't need it. We're only plugging in that 3. So that 3 is going to get substituted in here for x. Okay? So I'm going to have 2 times 3 plus the 0 for h, and then -4. Okay? So this is basically 6 minus 4, which is 2. So the limit, or not the limit, the slope of the line tangent to this function is 2. Okay? So that was number 5. I need to decide if I should switch over to the back. Will I have enough room for number 7? I should have enough room for number 7. Okay, so number 7. Speaking of which, where'd my black pen go? Number 7 is the same type of problem, but this time I have g of x, I'm just looking at that worksheet, equals 5 minus 2x, and the specified point is the point 1,3. Okay. Now, I'm going to go through the whole f of x plus h, f of x process, but I do want to point out that you already know the answer to this problem because this is linear. It's basically y equals mx plus b. And, oops, that's a b, not an h. And the m is the number in front of the x. So we already know that the slope is -2. So the answer is going to be -2. That's the slope. Okay? So I already know what the answer is. But let's go through the process just in case some of you might have forgotten that. You want to see the work involved with it. So for this problem, it's still g of x. So I would have the limit as h approaches 0 of, I'm going to plug, or I won't plug in yet. I'll just put g of x plus h minus g of x all over h. And then we'll start plugging stuff in. Okay? So we'll have the limit as h approaches 0. I know that the denominator is going to be h, so I'm just going to write that. And I'm plugging in for the x there, the x plus h. So I'm going to have 5 minus 2 times the quantity x plus h minus g of x is 2 terms, so we have to use parentheses, 5 minus 2x. Okay, and we have some distribution that we need to do. We have to distribute that -2, and we're going to have to distribute that negative. Okay, so I'll get the limit as h approaches 0 of 5 minus 2x minus 2h minus 5 plus 10x all over h. And then we can see that positive 5 and negative 5 cancel. And that is the only thing that cancels, right? Oh, what did I do? I multiplied a 5 times 2, but this is just a negative sign. So this should just be a plus 2x. My bad. I was like, something else should have canceled. What did I do wrong? And there it is, because those should have canceled. There we go. See how I caught that mistake? That's what you guys need to be doing also. Try to catch your mistakes, because sometimes we make some whoppers, and sometimes we make some really dumb ones, like that one. That one was a dumb one, but I mean, we all do it, okay? So, all right, so I have left -2h over h. H's cancel. All that's left is a -2, so we didn't need to plug in anything. That is the slope of the tangent line. So notice it's a -2, just like I said, okay? So if you notice that, you don't have to do any of this work. That saves you so much trouble. So if it's linear, your slope is the answer for the slope. Sorry if I sounded weird doing that, but I want you guys to remember. Okay, so that was number 7. Number 9. Okay, number 9 is g of x equals 4 over x at the specified point 2, 2. 2, 2. Okay, so this one's not linear, so we do have to go through the whole thing. Okay, so what color do I want to use now? I want to make it green. Okay, so we're going to have the limit as h approaches 0 of g of x plus h minus g of x all over h. And we're going to be plugging in that x plus h into that x right there in the denominator. And remember, we're not going to need the y value of that specified point. We only need the x value. Okay? All right, so let's start plugging stuff in. All righty. Let's make it teal now. So we have the limit as h approaches 0. I'm going to plug in the x plus h for the x there. So I will have 4 over x plus h minus g of x, which is just 4 over x, all over h. So yeah, we got a rational going on here, which means we're going to have to combine like terms, get common denominators, so all of that jazz. Okay, so for this one, I'm just going to focus on the numerator for right now. I'll worry about the denominator last. I need to get a common denominator. So they both have to have the same stuff. One of these has a factor of x plus h, the other one has a factor of x. So to make them have the same denominator, I have to just multiply them together. So this one is missing the x by itself. So I'm going to need to multiply top and bottom by x. This one just has the x and it's missing the factor of x plus h. So I'm going to have to multiply this one, bottom and top, top and bottom. Okay. So when I rewrite this, this is the limit as h approaches 0 of, I'm going to have this, remember this is all over h, so don't even worry about that part. But up here, the fraction in the numerator is going to be all over x times x plus h, or x plus h times x, it doesn't matter the order that you put those in. And the numerator is going to have a 4x minus, we're going to have to distribute that negative 4 to both those terms. So negative 4 times x is a negative 4x. Negative 4 times h is a negative 4h. Okay, and I don't know if you guys are noticing this, but these cancel. All right. And so we'll just have a negative 4h over x times x plus h over h. Sorry, I didn't mean to bump that. So what we got to do now is we need to convert this last fraction bar to a divide symbol. And then we're going to be dividing fractions because, you know, it's easy as pie. You flip the second and multiply. So let me zoom out a little bit. So I'm going to write it over here. So I have the limit as h approaches 0 of, I have negative 4h over x times x plus h. Now I have to divide by h. So let's put the h over 1, okay? Dividing fractions easy as pie. We flip the second and multiply. This is our second fraction. We need to flip that. When you find the reciprocal of h over 1, it's 1 over h. Hey, the h's cancel. That's what I needed to happen. Okay, so now this becomes the limit as h approaches 0 of negative 4 over x times x plus h. And now I'm ready to plug stuff in. We have this 0 that we need to plug in for h, and then this 2 up here. This is going to go in for the x's that are down there. Okay, so let's plug it in, and we don't have to write the limit now because we're plugging in numbers. So we have negative 4 over, we're plugging in a 2 for x, 0 for h. 2 plus 0 is 2. 2 times 2 is 4, so I have negative 4 over 4. Negative 4 divided by 4 is negative 1. So the slope of the tangent line is negative 1. Okay, so that was number 9. Oops, sorry, I keep bumping that. Number 9. Number 11, just moving along. H of x equals the square root of x at the specified point 9, 3. This one's also definitely not linear. Definitely. And I'm trying to decide what color I want to use. I want to use this royal blue. And let's get started. So we need to find the limit as h approaches 0. This time it's h of x, so h of x plus h. And I know in the video Mrs. Ardito changed that to a capital H, but as long as you know that that's function notation, it shouldn't be an issue. Or not plus, it should be minus h of x all over h. Okay, and now we're going to be plugging in that x plus h for the x there underneath that radical. All right, so next step, plug it in. So we have the limit as h approaches 0 of the square root of x plus h minus h of x, which is just the square root of x, all over h. Okay, so remember we're going to need to get this h to cancel. So we're going to have to rationalize, or reverse rationalize is what Mrs. Ardito called it, that numerator. So we need to multiply by its conjugate. The conjugate of that numerator would be the square root of x plus h plus the square root of x. The only thing that's different is the sign in between. That's the only thing that changes to make something its conjugate. But whatever we do to the top, we must do to the bottom. Okay. Now, for the bottom, you don't need to FOIL that out. We do need to FOIL out the numerator because the reason why we're multiplying by a conjugate is because we're getting stuff to cancel. We're trying to simplify it. We're trying to make it smaller. And by doing that, that's what makes it smaller because we know when we multiply by a conjugate that middle terms are going to cancel. Okay, so I'm going to get this set up over here. This is the limit as h approaches 0 of square root of x plus h times itself means that the x plus h gets to come out. Square root of x plus h times square root of x. I'm not even going to write. I'm just going to remember that in my head. Positive square root of h, or square root of x plus h times square root of x, and then minus negative x, or negative square root of x times the square root of x plus h. So I have a positive version and a negative version. They're going to cancel each other out. Remember, the middle terms cancel. And then negative square root of x times positive square root of x is negative x, because square root times square root means the stuff inside gets to come out. Okay, so that's done. All right, in the denominator, I'm just going to write, I'm not going to overthink this. I'm just going to put h times the quantity, square root of x plus h plus the square root of x. Do not multiply that out. Okay, so look at what we've got. Look at what we've got here. Getting all tongue-tied. These x's cancel, so we'll just have h over this, which means that I can then cancel the h. So now I have the limit as h approaches 0. Since everything in the numerator canceled, everything left is a 1, because that's what it means, cancel stuff out. You're reducing the fraction. So it's 1 over the square root of x plus h plus the square root of x. Okay, we got the h to cancel over here. So now we are ready to plug stuff in. Plug and chug. Okay, so what are we plugging in? Well, remember, we don't use the y value. We're going to be plugging in this 9 for the x's and the 0 for the h. So I'm going to have 1 over 9 plus, square root of 9 plus 0 plus the square root of 9. Okay, well, 9 plus 0 is just 9. The square root of 9 is 3. Square root of 9 is 3. So this becomes 1/6. So that is the slope of the tangent line. Okay. Next, can I fit number 12, or not number 12, number 13 here? I don't think I can. So I'm going to get another sheet of paper. I have a stack all ready to go for you guys. All right, number 13, moving right along. It's in the next section of problems. It says, find a formula for the slope of the graph of f at the point x, f of x, then use it to find the slopes at the two specified points. So they want us to do what we've been doing, do the whole limit f of x plus h minus f of x all over h, but then plug in these x values and see what the slopes are at those given points. Okay, remember, we don't need the y values for these, so who cares what they are? I don't, because I don't need it. So that's what we're going to be doing for number 13. Okay, so first of all, let's write it down. It is g of x equals 4 minus x squared. Okay, all right, so write our limit. It's the limit as h approaches 0 of g of x plus h minus g of x all over h. Okay, remember, we're going to be plugging in that x plus h for the x here. All right, so when we rewrite this, it'll be the limit as h approaches 0 of 4 minus the quantity x plus h squared. I have to put this in parentheses because I have to square it, and then after I square it, I'm going to have to distribute that minus sign, so it's important to have parentheses there. minus g of x, and g of x is two terms, so again, I need parentheses because we'll have to distribute that minus sign all over h. Okay, so there's that x plus h quantity squared again. Remember, that multiplies out to x squared plus 2xh plus h squared. Okay, because it's x plus h times x plus h. So let's rewrite it. We've got the limit as h approaches 0 of 4 minus the quantity x squared plus 2xh plus h squared. And then I'm going to go ahead and distribute that minus sign. That would be minus 4 plus x squared, and then all over h. Okay. And while we're here, so we don't have to rewrite it again, let's go ahead and distribute that minus sign. So when I distribute the minus sign, this x squared is now negative. This 2xh is now negative. And this h squared is now negative. Everything was positive, so now everything's negative. All right, so let's see what cancels. I have a positive 4 and a negative 4. Cancel. I have a negative x squared and a positive x squared. Cancel. And looks like that's it. So let's write what's left because that looks crazy. I'm going to rewrite it. So I have a negative 2xh minus h squared all over h. Okay. And I'm going to rewrite it one more time because I want to factor out an h. If I factor out an h that they have in common, I'll be able to cancel out that one in the denominator. So I'll have an h out front and then negative 2x minus h left inside when we divide out an h all over h, and we could factor that out. Notice I didn't write the limit because I forgot and I got a little lazy. That's okay. As long as you're doing it and you're remembering to do it as you go towards the end, I'm not too worried about that because you're getting ready to plug in numbers. All right, so what do we need to plug in? We're going to be plugging in 0 for this h right here. And, oh, did I write down? Nope, I didn't write down the points. So part A, the point was 0, 4. And for part B, the point was negative 1, 3. Remember, we don't care about the y values, but we care about the x values. That is for sure. Okay, so for part A, and I'll just write part A down here, since I know what this is going to be, it's negative 2x minus h. This is the final equation I'm going to be plugging into. So plugging in a 0 for h is going to be, just negative 2x. And then when I plug in a 0 for the x here, I'll have negative 2 times 0 minus 0. Well, what is that? That's 0. Everything's 0. Okay. And there we go. For part B, I do the same thing, but this time for x, I'm plugging in a negative 1. So negative 2 times negative 1 minus 0. Negative times negative is positive, so this ends up being positive 2. So the slope of the tangent line at the point 0, 4 to this function is 0, and the slope of the tangent line at the point negative 1, 3 is 2. So that was 13. We have 2 more problems left to do. 15 is next, and that's still in the same group of problems. It was hard to see these, but again, I wrote them on a blue Post-it, and you saw the blue Post-it and what I wrote on the assignment, so hopefully you clicked on that. If not, look at the attachments I attached, because I attached them for a reason. If I ever forget to attach something, just let me know, because I do make mistakes, especially because I am multitasking big time when I'm preparing these. So I'm not only teaching you guys, I have to teach my own kids too. And my daughter's easy, my son, not so much. But that's okay. It's getting better. I can honestly say it is getting better, so he's starting to accept the fact that I am his teacher and his mommy. All right, here we go. So we have g of x equals 1 over x plus 4, and we need to find the slope at these specified points. So first of all, we need to find the slope equation, which is why we use the limit process for that. So this will be the limit as h approaches 0 of g of x plus h minus g of x all over h. Now you might be tired of having to write that for every single problem, but honestly, guys, the only way something sticks in your head is to be repetitive, especially with a formula, okay? So especially because you guys aren't used to having to memorize things on a regular basis. Like when I was growing up, I had to memorize things all the time. I had to recite like the Gettysburg Address in my 6th grade class in front of the whole class. And that was a long essay to have to memorize. And I had to keep doing it until I said it perfect. So like you guys don't have to do that kind of stuff anymore. That's very old school. But in order to kind of sharpen your memories, repetition really does help. Okay, anyways, that's speech over. Let's go ahead and plug in the x plus h for the x there. We are going to have a fraction over a fraction. So we're going to have the limit as h approaches 0. So obviously everything's going to be all over h, okay? And then we need to plug in x plus h for that function there. So that's 1 over x plus h plus 4, okay, minus 1 over x plus 4. All right, so don't overthink it. Yeah, that's 3 terms, but we can't combine them. There's nothing in common. And yeah, I got to get a common denominator. So to make them have something in common, we have to multiply them together. So I'm going to have to multiply this one top and bottom by x plus 4. And this one top and bottom by x plus h plus 4. Because they are not the same factor. They are 2 distinct, 2 different factors. Okay. All right, so let's clean this up a little bit more. We're going to have the limit as h approaches 0 of, I know that everything is going to be all over h in the denominator. In the numerator, the denominator of the numerator is the x plus h plus 4 times x plus 4, or vice versa. You don't have to write it in that order. You could put the x plus 4 first if you wanted. In the numerator, I'm going to have 1 times x plus 4, which is just x plus 4, minus 1 times this. Well, 1 times x plus h plus 4 is still x plus h plus 4, but we have to distribute that minus sign to those 3 terms. So since all 3 are positive, when we distribute a negative to them, all 3 will become negative. So that will be a negative x, negative h, and a negative 4. Okay, now let's get a little cancel happy. Cancel some stuff out. We have a positive h and a negative h, positive 4 and negative 4. Okay, and let's rewrite this. So this will be the limit as h approaches 0 of, in the numerator of the numerator, I have a negative h, and that's it. All over, I'm going to put the x plus 4 first, because I do like having the smaller factor in front. You guys know that about me. It was bugging me. I was trying to not let it bug me, but it bugged me. And this is all over h. Okay, when we have the double fraction bar going on, remember we take the bottom one and we convert that to the divide symbol. And it's dividing fractions, easy as pie. Flip the second and multiply. So when we write this, it'll be the limit, I won't be lazy this time, as h approaches 0 of, let's see, it's negative h over x plus 4 times x plus h plus 4. And remember, divided by h over 1. So times the reciprocal 1 over h. Dividing fractions easy as pie, flip the second, multiply. Okay, and the h's cancel like we want. That is our goal. We hit our goal. It's like when our watches go off after we've done more activity than we normally do in a day, and I kind of like that when that happens. I don't know about you. There's that negative in front of h, so it's going to make this 1 negative, because negative times positive is negative. All over x plus 4, x plus h plus 4. Okay, we are ready to plug stuff in. So we're going to plug in that 0 for the h. Okay, and I'm gonna go ahead and do that now. Save me a little bit of time for the 2 parts, the a and b part. So I'm going to have x plus 4, and then because the h is 0, I'm going to have x plus 4. Okay, so now for part A, we don't worry about the y value. We just have to plug in an x value of 0. So I'm going to have negative 1 over 0 plus 4 times 0 plus 4. Well, 0 plus 4 is 4, so we have 4 times 4 there. So this is negative 1 over 16. So negative 1/16 is part A. And then for part B, I have to plug in a negative 2 for x. Okay, so let me move this up a little bit. Part B, I'll have negative 1 over negative 2 plus 4 times negative 2 plus 4. Well, negative 2 plus 4 is 2, so 2 times 2 is 4. So this is negative 1/4. And those are the slopes of the tangent lines at these points to this curve on the graph. Okay, so that was 15. One more problem left, and I'll be able to put it on the back of this paper so I don't waste another paper. Although I find myself using less paper because I am doing mostly everything digitally. Where did my black pen go? Oh, I put it back. Okay, number 17. And this one was the other one that was hard to see. It was g of x equals the square root of x minus 1. Our part A is to find the slope of the tangent line at the point 5, 2 and at the point 10, 3. But honestly, they give us the coordinates. All we care about is the x value again, so just keep that in mind. All right, so for this one, we're going to have the limit as h approaches 0 of g of x plus h, because we're going to have to plug that into the g function, minus the g function all over h. And this is the x that we need to substitute. Okay, so I hear my son laughing, a little curious about what's going on back there in his room. All right, the limit as h approaches 0 of plugging in an x plus h for the x there, I'll have the square root of x plus h minus 1 minus the g of x function itself, which was just the square root of x minus 1 all over h. Can't combine anything, can't do anything, except we've learned to reverse rationalize, as Mrs. Ardito calls it. So that means I have to multiply top and bottom by the conjugate of those rationals. So the conjugate would be the square root of x plus h minus 1 plus the square root of x minus 1. And whatever we do to the top, we must also do to the bottom. Okay, and we will have to FOIL out the top because that's where the conjugates are and stuff's going to cancel. We will not need to distribute the h. Don't distribute the h. We want the h to cancel. In order for it to cancel, it needs to stay out front. Easy access. Okay. All right. Let's multiply this out. Well, let me get this ready first. So, limit as h approaches 0 of, all right, square root of x plus h minus 1 times itself means the x plus h minus 1 gets to come out. Can I zoom out more? Nope, I can't. All right, and then square root of x plus h minus 1 times square root of x minus 1. This is the positive version. Negative square root of x minus 1 times square root of x plus h minus 1. That's the negative version, so they will cancel out. And then negative square root of x minus 1 times itself means we'll have negative, and then the x minus 1 gets to come out. But because it's two terms and it's following this minus sign, we have to put parentheses around it. Okay, all over the denominator, remember I said don't multiply it out. It's just h times the quantity, square root of x plus h minus 1 plus square root of x minus 1. Oops, I need to close parentheses. Okay, all right, so let's see what happens in the numerator here. In the numerator, we distribute that negative, so this will be a negative x. Negative times negative is positive, so that's a plus 1. Okay, so I have a negative 1 and a positive 1 that will cancel. And I have a positive x and a negative x that will cancel. So all I have left is that h up there like we wanted. So one more time, the limit as h approaches 0 of, all I have there is an h over h times the square root of x plus h minus 1 plus square root of x minus 1. And the h's cancel like we want. So I'll rewrite it over here. So now all I have left is 1 over square root of x plus h minus 1 plus the square root of x minus 1. Males here. All right, now we can start plugging stuff in. We know that we're going to plug in a 0 for the h, so let's go ahead and do that. So I will get 1 over the square root of h is 0, so it goes away pretty much. So x minus 1 plus the square root of x minus 1. And I'm going to go ahead and simplify that because I have 2 of the same radical there. So I have 1 over 2 square root of x minus 1. All right, now let's go back and let's plug in those x values. Remember, we don't care what the y value is. We only need the x value for these. So part A, we're going to plug in a 5 for the x. So let's plug a 5 in there. So I'm going to have 1 over 2 times the square root of 5 minus 1. Well, 5 minus 1 is 4. The square root of 4 is 2. 2 times 2 is 4. So this is 1/4. So that's the first slope. Okay, 1/4. And then for part B, I'm going to have 1 over 2 times the square root of, what are we plugging in for x? We're plugging in a 10. So it'll be 10 minus 1 under that radical. Okay, 10 minus 1 is 9. The square root of 9 is 3. 3 times 2 is 6. So I get a slope of 1/6. All right, and that's it. I'm sorry this one's kind of long, but it has a lot of explaining, and I did kind of go off on a tangent on some things, but that's because I miss talking to you guys. I'm used to talking all day long, every day, and then not so much. So I miss you guys. I hope you had a wonderful May the 4th and continue to have the Star Wars vibe the whole rest of the week, and have a good one. I'll see you guys in my next video.